All right, our focus today will be based on the double integrals. Let me say now we are given the following a problem which we have to integrate. By looking at the problem, we have two integrals. We need to be able to know where to start when we want to solve this type of a problems. So the first thing that you need to note is to identify the outside antiderivative. So the outside integral correspond to dx. This is the outside integral. And then the inside integral correspond to dy. This is the inside integral. Therefore, when you want to integrate, you have to integrate from the inside to the outside. It means then now we are going to start integrating from the inside. The antiderivative with the limits ranging from 1 to 3, given the function xy squared dy. We have to find the antiderivative of the function xy squared. Then when we integrate with respect to y, it means we are going to keep x as a constant and then we integrate y squared. This is going to be x. The antiderivative of y squared is y cubed over 3 because we add 1 on the exponent and then we also divide by the number. So the limit ranges from 1 to 3. I'm sure you'll get that very simple. So by doing this, since we have two variables, it can be useful for us to identify like which one is x and which one is y. Since the limits which we want to substitute are the limits of y, we can indicate that this is y, this is y, so that we don't confuse x and y in this problem. And then when we are here, you can substitute y with 3. Whenever there's y, you can first substitute with 3 and then you subtract 1. And then we are going to have a x, y, and then when there's y, you replace with 3 to the power 3. All this is over 3 minus x. Then when there is y, you can put in 1 to the power 3. All this is over 3. So we have x 3 to the power 3. What is 3 to the power 3? 3 to the power 3 is simply 27. It means now we have 27x over 3 minus x 1 to the power 3, 1 to the power 3, 1 to the power any number is the same as 1. It means now we have x over 3. Then when we check, the two have the same common denominator, which is 3. It means now we are going to have 27x minus x. What is 27x minus x? The two are like terms. It means we have 26x, all this is over 3. It means now the inside function can now be replaced by this. So this is what we have at the moment. Then the outside limit ranges from 0 to 2. And then the inside antiderivative is now replaced by 26x over 3. And now we have to integrate with respect to x. Then this is dx. All right, when we check, 26 over 3 is a constant. We can take it out as 26 over 3. The antiderivative ranges from 0 to 2. Inside we'll have x dx. So from this step, you need to be able to see that the problem is now very simple to integrate because we just integrate with respect to x. Bear in mind, this is antiderivative, not differentiation. It means now we'll have 26 over 3 as our constant. Then we integrate x with respect to x. It means now we're going to have x squared over 2. The limits will ranges from 0 to 2. Then this is equal to 26 over 3. Then now where there is x, we have to substitute 2 because the limits ranges from 0 to 2. Therefore, 2 is the upper limit. And then it is 2 to the power 2. All this is over 2. And then everything minus 0 will just be 0. Because if we substitute x with 0, we'll just get 0 as it is. And then now our final answer will be 26 over 3 multiplied by 2 to the power 2. 2 to the power 2 is just 4, and then 4 over 2 is 2. So it means now we have 26 times 2, which is 52 over 3. Because we all know that 26 times 2 is like 20 times 2, and 20 times 2 is 40, and then 40 times 10 is 15, then 50 plus 2 is 52 out of 3. Therefore, this tells us that when we evaluate the double integral, this is the final answer that we must get.